Hello, good morning students. So today we can discuss about AC through pure inductance or inductor. It means when pure inductor or inductive coil is connected across the AC supply, what will be the property of this inductor we are going to discuss. For that, so you can consider the circuit diagram, that is pure inductor or inductive coil you take and connect to alternating supply. Then its performance will be discussed in terms of the vector diagram, waveform, in that the voltage and current relationship, and in the fourth figure, the relation between the power, voltage and current, and the important properties of the pure inductor when it is subjected to the AC we are going to discuss. So in figure 1 you can see here a pure inductive coil is connected across the AC supply. The term pure inductive coil, why I am talking, or why it should be called as the pure inductive coil? The answer is the current and voltage will be having the phase difference of 90 degree. You can see here I is lagging E by 90 degree. So the element which is having this type of property will be having the displacement of current and the voltage by 90 degree. Such element will be called as pure inductive coil or pure inductance or pure inductor. So mathematically, if the equations are going to be considered, you can see I is equal to the expression of the inductive coil's current is I equal to I maximum sine theta minus 90 you have to consider. It means current is lagging the voltage by 90 degree, whereas the applied voltage having no minus 90 or plus 90. Why? Because it is a source. So its effect will be lagging or leading. So source will be remaining as it is. E is equal to A maximum sine theta. So that can be seen in the vector diagram as well as in the waveform or the phasor diagram. I is lagging E by 90 degree where it is shown, and at the same time I told you the EMF will not be expressed in terms of the lagging or leading, whereas the current its effect will be having the property of lagging or leading. So the equation is presented here I maximum sine theta minus 90. It means I is lagging E by 90 degree. Vectorially also you can see that the phase angle difference between the E and I is 90 degree. The same can be understood in the waveform also. Now you see the voltage is having the maximum value at 90 degree. It has reached to the peak value or the maximum value, or it is also called as the amplitude at 90 degree. Then current is going to be started from this reference line. That is the meaning of lagging. And voltage is high, current is about to start. Then when current is high, voltage is going to be starting in the negative direction like that. They will be having the phase difference of 90 degree, that can be seen in the waveform also. Considering this, the variation of the voltage and current, we can explain about the power developed in the inductor. Dissipated we can't say here. Why? Because the pure inductor will not dissipate any power. The active power dissipation in case of the pure inductance will be zero. That I will show you here. Assuming that this is a negative, quarter pulse positive, quarter pulse negative, once again positive. So like that. So you can represent the P, V and I on the y-axis, whereas the time on the x-axis. You can see the voltage waveform which is shown here. The current waveform, the same here, it is taken through the 90 degree. Then you can see quarter pulse of the voltage waveform, quarter pulse of the current waveform will be giving you the negative power pulse. Similarly, here two positive quarter pulses of the voltage and current, if they are multiplied together, you will be getting here the positive pulse. It means in half of the cycle, two pulses, one positive and negative, you are getting. Pair of the pulses you can see. So then the next, for the negative half cycle, also you will be having one negative power pulse, because here one positive pulse of the current and the negative pulse of the voltage will be giving you to shift the power pulse below the reference line. Similarly, here two negative will be making positive. At each and every quarter position, you will be having the two couple of what is known as the pulses. That is for half cycle, positive, negative. For remaining half cycle, positive and negative pulses you are getting. That show that both will be cancelling out each other, and you will be having the power developed in the pure inductance or the pure inductive coil will be zero. Which power? Active power. Whereas the property is concerned, you will be having the clear idea here. Voltage and current, they are out of phase with each other, where the phase angle difference between the voltage and current will be 90 degree, and it is clear that I will be lagging V by 90 degree, and active power Vi cos phi will be 0. Why? Because mathematically, if 90 degree is the phase difference between the voltage and current, cos 90 will be equal to 0. Similarly, reactive power, if it is concerned, sin phi, if it is considered sin 90 degree, that will be 1. That means the reactive power is very high. Whereas the active power, if it is 0, it doesn't do any action. Any electrical action, it does not show pure inductive. That's why the reactive power, it is accumulated in case of the inductive coil, that doesn't do anything. Whereas the apparent power is concerned, which is the product of the voltage and current without the multiple of cos or sin, that will be measured in volt ampere or kilovolt ampere if any it is developing. But normally the reactive power will be 0. So normally reactive power will be, that is there, very high, whereas the active power will be 0. So therefore the nature of the apparent power will be same as the reactive power. So the reactive power and the apparent power, they will be similar here. Why? Because there is no active power in case of the inductance. So in detail, further we can talk about the property of this pure inductance in the next lesson. Thank you.